Okay, coterminal angles. We're going to talk about coterminal angles today, reciprocal trig functions, and all of these are in conjunction of angles in standard position. Angles in standard position simply means that we're drawing our angle on the four-quadrant plane with the vertex of the angle at the origin. So you should have started working with angles in standard position last year in grade 11. We're going to continue that work in grade 12. We're going to introduce a new unit for angle measurements, and we will introduce some new terminology, and we're going to also today work with reciprocal trig functions, okay, which you haven't seen before. Coterminal angles, when we're talking about angles in standard position, mean they have the same terminal arm. So if we define our angle in standard position to have an initial arm, which is on the positive x-axis always, the terminal arm defines the angle. So wherever the terminal arm is, that's where the angle ends up, and that's what terminal means, ends, okay? So in this case, we're saying an angle of 100 degrees, so it's positive, which means we go counterclockwise, up and to the left, and our terminal arm is here in the second quadrant, okay? Everybody all right with that? So coterminal angles mean that we want to have the same terminal arm as that. So we want another angle different from 100 degrees, but that also ends up right there. Any guesses as to what that might be, or one angle might be? Cassie might want to take that out of your ear so you can hear better, okay? Any guesses to another angle that would end up right there on that same terminal arm? 460 degrees. How did you get that, Demetria?
I just added 360, which would go all the way around.
Correct. So if we add 360 to this, go one more time around, we get back to that same terminal arm. Any other suggestions? So we said negative 260 degrees. We said positive 820. So in general, we're taking that angle that we started with, and we're adding multiples of 360. And they're multiples that are both positive and negative if we let n be an integer. And that's the symbol for an integer. So if n is any integer, that means it's a positive number or a negative number. If it's positive, we're going to add multiples of 360. If it's negative, we're going to subtract multiples of 360. And that's going to give us all the coterminal angles. Okay? Questions about that? Okay then. Angles in standard position. We talked about this already at the beginning of class. When we talk about an angle in standard position, we're going to use a point P to define a point on a unit circle in standard position. So in a quadrant that defines an angle in any quadrant, 1, 2, 3, 4. Now, a unit circle, all that means is that the radius is 1 unit. Okay? So a unit circle has radius of 1. And why that is nice is when the radius is 1, then when we say sine is y over r, then really sine is just y. And when we say cosine is x over r, then cosine is just x because r is 1, and dividing by 1 doesn't change anything. Okay? If x and y are the two coordinates here, then x squared plus y squared will always equal the radius squared, which in this case is 1 squared or 1 on a unit circle. Okay? So that is convenient for us to be using the unit circle. So we have we had cos theta, let's say this, cos theta was x over r and sine theta was y over r. Okay. On the unit circle, cos theta will be equal to x, and sine theta will be equal to y, because r is equal to 1. Now that allows us to define the reciprocal trig functions, okay? And the reciprocal trig functions are exactly what they sound like, the reciprocals of the trig functions that you already know. So the three functions that we're going to define are secant, cosecant, and cotangent. Okay, so those are new to you this year. Secant is the reciprocal of cosine, 1 over cosine. Cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. That's an easy one to remember. The other two, people sometimes mix them up because cosecant doesn't go with cosine. Okay? Now, the short forms or the abbreviated forms are SEC for secant, CSC for cosecant, and COT for cotan. So using our unit circle, what that means is that this secant is 1 over x, cosecant is 1 over y, and cotan is x over y. When the radius is 1. So I'm going to do some examples of the kinds of problems you're going to see, and we're just going to power through this today. I realize it's not ideal. It's a drunk driving assembly. Okay? Okay. So we're going to do some work with the reciprocal trig functions and angles and standard positions. So you'll see the kinds of questions we're talking about in this section. So I'm going to scroll it up. Okay? Okay. One thing to keep in mind, you have learned about second sine on your calculators before when you're using it to find angles. But this, when you see this symbol, sine to the minus 1, it does not mean 1 over sine. Okay, they are not the same. Okay? Now, normally I would assign these questions right now, but I am going to assign them, but we're going to go a little bit further with some examples, okay? Just simply because of the timeline. And I'll change my view so it's not so huge. Okay, so we're going to find the exact value for all 6 trig ratios for negative 420 degrees, okay? Just come and join us over here, Matt. Or maybe over there, I guess. Okay, so we have negative 420 degrees. We want sine, cosine, tangent, cotan, cosecant, and secant. All 6 of them. Okay, 3 of them are new to you this year. Negative angles mean that we're going to go clockwise. So we start at the positive x-axis, and we'll travel clockwise. Which quadrant do I end up with in negative 420? Where does negative 420 end up? Sandrine? Quadrant 4, so we're going to go around 1 time, is 360, and then we need to go another. How far? What's that reference angle there? Henrik? 60 degrees. So we have a reference angle of 60 degrees. And that's important. We need to know those 2 things. We need to know which quadrant and what reference angle are we talking about. Because if we have a reference angle of 60 degrees, that tells me that I need to use my special triangle. That's the 30, 60, 90 triangle. And when it's in fourth quadrant, it tells me that everything is negative except which trig ratio? Cosine, and now also 1 over cosine. And what's 1 over cosine called? No. 1 over cosine is the secant. So cosine and secant are positive here, but everything else is negative. Okay? So let us think about 60 degrees. 60 degrees, the sine of 60 degrees, thinking back to our special triangle, is root 3 over 2. So the sine of negative 420 is root 3 over 2. Only in fourth quadrant sign is negative. So we'll have negative root 3 over 2.
So in quadrant 4, the ones that are positive is tan and
In quadrant 4, the ones that are positive are cosine
oh.
and the reciprocal of cosine, which is secant.
Oh.
Okay? So cosine of negative 420, if we look at our special triangle, cosine of 60 degrees is 1 over 2, and in fourth quadrant, cosine is positive. Okay? So let's complete the rest. Okay, so tan of negative 420, what do you get for that one? Aaron? Negative root 3, correct. Negative root 3, okay? Now, cotan of negative 420, all you have to do is take the reciprocal of tan. Cotan is 1 over negative root 3, so that's negative 1 over root 3. Cosecant is the reciprocal of what? Sine, so the reciprocal of that is negative 2 over root 3. And secant is the reciprocal of cosine, so secant negative 420 is 2. Okay? Are we all right with that? We just flipped them over. The positives and negatives stayed the same. Just take the reciprocal. Questions about that one? Okay. And you'll do that for any of them. If I ask you to find cotan, finding tan is the easiest way to do it. All right, we'll do another one. Let's say we have 586. We're going to find the sine, the cosine, the tan, the cosecant, the secant, and the cotan of 586. So give that, okay? So 586 is in the third quadrant with a reference angle of 46 degrees. It's not a special triangle. You can't find exact values. So what do you have to do then? If you're going to evaluate sine 586, Sandrine? X, Y, Z. If you knew the point, but you don't know the point, right? If I gave you the point on the unit circle, you could find them, but I didn't give you those values. So how can you evaluate the sine of 586? If it's not a special triangle, a special angle, you have to use your calculator. So you would just put it into your calculator. Now, make sure your calculator is in degree mode. The default setting of your calculator is not degrees. So go to the mode on your calculator. Which is that button there. And if radian is highlighted right now, you don't want radian highlighted, you want degree highlighted. And then you can say sine 586, cos 586, tan 586, and so on. Okay. So put those into your calculator. What's the sine of 586? Andrew? Andrew Eng? 0.719. Okay, and the cosine of 586, Curtis Bussey?
Negative 0.695.
And the tan of 586, Pun?
1.03.
Okay, and the cosecant of 586, Roxana? Yeah, so exactly. So in order to calculate cosecant on your calculator, because you don't have a cosecant button, you do have to do 1 over, and in your case it would be sine 586. So you would put that into your calculator. If you put in the 1 over negative 0.719, you will have a rounded off value because that's rounded off. So better to go back to the original sine 586 and you get negative, what, Roxana? Okay? And then the same thing for secant, you're going to do 1 over cosine 586. And for cotan, you're going to do 1 over tan 586. So what is the secant, please, Cassie? You have to say it loud for me. I'm tied to my... -1.439. 4.3? Sorry, say it a little bit louder for me.
-1.439.
Thank you. Okay, and then 1 over tan 586. What do you get there, Jamie? Okay? So as a test question, it would be a little bit more clear. Can I talk to you at lunchtime?
Quick question. After 1, 2, 3, 5.
Get one time for one more example here. Okay, so here's another typical question. This time, so Sandri, now I'm giving you the point, okay? The point -1, -4. And you're going to determine exact values of the 6 trig functions of the angle and center position defined by P on the terminal arm. Okay? So the point now is the point -1, -4. So it's down here in the third quadrant. Okay? When you know the point, you can draw the triangle in that quadrant. Okay? We want to draw the triangle so that there's a reference angle, and the reference angle is always measured to the x-axis. So we want it measured here along the x-axis. And then we can label the sides of the triangle -1 and -4, the x-coordinate and the y-coordinate. And we can figure out the radius. How do we figure out the radius? We use the Pythagorean theorem. So r squared equals -1 squared plus -4 squared. So r is equal to root 17. Okay, are we all right with that? And now we are just going to determine the 6 trig ratios using SOHCAHTOA and the reciprocals. So sine is opposite over hypotenuse. So this angle here, the reference angle here, the opposite side is -4. The hypotenuse is root 17. So we have -4 over root 17. And so on. Can you determine the other 5 trig ratios? We are going to keep going, even though if the bell goes, we'll just finish this question off. It won't take very long, okay? What are you getting for the cosine of theta then? Colin Olson? A little bit louder for me, please. -square root 17. How are you getting that? Cosine is? Yeah, adjacent over hypotenuse. So -1 over root 17. Tangent theta is what? Greg?
4.
Is +4. Very good. Then we're into the reciprocal trig functions. We just have to reciprocal them. So we get 1 over 4. We get -root 17 over 4. And then secant is the one that's -root 17. Okay? Try some of the 6.1 questions tonight.